I'll start handing them out and we'll see how many gets around. Just pass them along. Oh, maybe that might be. I see you. How are we doing? Need some more? Maybe I have enough. Is there enough or too many? No, need some more? Some more? Two more. One more. One more. One more. Okay, hey, listen, I know you're all excited that you have your maths workbook, so just calm down. Okay. This is the semester 1 workbook. This is common maths for every student. And as you can see just from the table of contents, it's all the basic high school maths: algebra, sequence and series, logs, trigonometry, calculus and probability. Okay? So this is the basic stuff. In semester 2, the engineering students will get their book and the business students will get their book. For the moment, you can all be together for this lesson. So we're going to start with the algebra. You don't need this just yet. We'll use this a little bit later to do some examples. I made this workbook have many, many questions, not because I want you to do every question, because there are thousands of questions, but I want to make sure that people have enough questions they can practice as much as they want. Because sometimes the weak students, they ask me for more questions. And by giving you this, I can say to the weak students, well, if you want to be good, just do all the questions and you will be. Okay? But for the students who are average or very good, it's crazy to do all of these. There's loads of questions here. So I will tell you how many you should do for homework, and if you want to do extra, if you feel you need to do extra, then do extra. There's plenty here. Okay. So we'll start with the algebra then. Not too difficult to start with. So if you all have your notebook, pen and paper, please. Can everybody see okay? Yeah. A bit maybe slide down here. Right, so like I said earlier this week, listen, like I said earlier this week, the reason I use my laptop to write instead of the board is because I can record this lesson. So if you miss something, or I'm going too fast, you can just watch it again later. So everything here is recorded. So if you can write this down, we're going to start with equation of the line. So just some basic revision from middle school. I know you know this. Of course you do. But what I want to know is if you know the English name for this. X axis. Yeah, good. Okay, and this one, of course, is the y-axis, and this point here. Yeah, its name. Origin. Yeah. And what's this called? Yeah. What's a simpler word though? Just a point, yeah. This is just a point, but each one of these has a name. This one, somebody said, is the x-coordinate and the y-coordinate, yeah. So right now I'm just making sure you all have the basic words that you need. So if you can write these names down, just make sure you have them. And this graph is called what? We don't just call it a graph. What type of graph is it? Graph. Yeah, so what type of graph? Perhaps it could be an x. Well, it could be linear, but more generally, maybe just an xy graph. And there's another name for it, though. Cartesian graph. Why didn't I just say so? Yeah, Cartesian graph or xy graph. Probably you'll call it xy graph. Is there? Give me a clue. What could it be? I'm trying to think if there is another one. Oh, well, perhaps you could call it horizontal and vertical. That's not what you're thinking? If you think of it too, tell me, please. I would just call it x and y axis. Okay, do you have all those names written down? Yeah. Okay, so you have this? Yeah? Yeah, okay. Okay, so just as a first example, plot, we'll say 1 minus 2 on a xy graph. This is a first example to get started. So this is easy peasy, lemon squeezy, yes. So we'll just say 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3 here, and then minus 1, minus 2, minus 3, and we must write. If you forget to write this, you will lose a mark in the exam. Must write x and y here. Forgetting that will cost you 1% in your exam. Don't do that. So x and y. So this one here, this is the x and this is the y. So we go 1 point along the x, and then because y is minus 2, we go down here. Yeah. By the way, these must be the same, obviously. And must these be the same as these? What do you think? Yes. For example, could I do this? Could I say 1, 2, 3, 4, 1, 2? No. I can or can't? Can? Can't? Can? You can. Yeah. This is okay. You're allowed to do this. You're just not allowed to change the units on an axis, but they can be different. This is allowed, okay? And in fact, sometimes it's convenient to make it different for making the graph. So this is okay. All right, let's continue then. Oh, sorry, did you write this down? Yeah. Yeah. Question? Yeah. For some people it does, but I'm not too fussy. When I'm marking this in the exam, what I want to see is an x and a y, and that these are the same distance apart. That's what I care about. Okay. Next now. So if we have one point here, x1, y1, and we have another point here, x2, y2, it's not too difficult to find this point here, which is exactly in the middle of the 2 points. And this point has a name, midpoint. Now, does anybody, I'm sure many of you remember from middle school how to get the midpoint. Does anyone know the formula? Divide 2, yeah, and then y1 plus y2 divide 2. To me, I also like to think of the midpoint as like the average point. Because if I had 3 points, I could still find the point in the middle by doing something similar. By adding the 3 points together and dividing by 3. This isn't something we will really do, but I just want you to understand that it's the same idea. That midpoint is like a average between all the points. It's a center point nearly. Yep. Okay, so let's try a simple example of this then. Let's say example. So if you can write this down as well. Find the midpoint between let's say -2, 6 and 1 minus 2. It doesn't matter, of course, which one you say is x1, y1 and which is x2, y2. So I'll just call this one x1, y1, and I'll call this one x2, y2. So the answer will be -2 plus 1 over 2 and 6 plus then -2 over 2. Yeah? That is going to be, what's that, -1/2? Yeah, and then 2. Yeah. Okay, so that's our first midpoint example. So if you can write this down, please, and then we'll continue. Got that? I can scroll down? Yep, okay. Right, so far we've only been talking about points which aren't too interesting because there's only so much you can do with it. So now we're going to have a look at lines. So, for example, how to represent a line. So, for me the most useful way to represent it is in this form, as an equation of the form y equals mx plus c. For the American students, that's mx plus b, and some crazy people out there may even use ax plus b. That is fine, I will not judge you. I prefer to use it like this, mx plus c. Yep. X, y. Now, of course, this isn't the only way to represent a line. You can represent a line in this form, ax plus by plus c equals 0. Both have advantages and disadvantages, but I feel like this form has the most advantages because the m and the c is something quite useful to know. So just as a small example, we just want to practice changing it from this form into the previous form. So for example, the line L is given by, let's say, 5x plus 7y, let's see, 5 plus 6 equals 0. And my question is, write this in the form y equals mx plus c. Okay, so let's have a look here. We want to take this and write it in this form. So we have 5x plus 7y plus 6 equals 0. The first thing I should do, I should bring the 6 over to the right. And then the 5x as well. 7y equals minus 5x minus 6 then, yeah. And then we can continue. Guys, it's fine to work together, but don't talk when I'm talking, and definitely don't talk in Chinese when I'm talking. Okay, nearly finished. One thing left to do here. Divide by 7. So we can divide both sides by 7. So basically we can bring the 7 down here. And then we get, finally, y equals minus 5/7 x minus 6/7. If this was an exam question and you left it like this, you wouldn't actually get full marks, because my question was to write it as mx plus c, not mx plus c over some other number. So you have to separate it at the end. This is the type of mistake that would cost you a mark in the exam, things like this. So this is the answer here. There is a way to describe what I did by making the y be by itself on the left. Does anybody know in English how to describe what I did, what I want here? I said by making the y what? I mean, I could say by making the y be by itself on the left, but there's a nicer way to say that. Does anyone know it? Solve for y is a very nice way to say it, and that is okay too, but I was thinking of something else. But solve for y is okay. That's the one, yeah. So, to describe what I did here, make y the subject. Somebody else said solve for y, which is fine. So please note those two expressions there. Make y the subject and solve for y is how you can describe what we just did. Okay, let's continue then. Okay, you all have that, yeah? Yeah. Right, so we were saying that y equals mx plus c. That represents a line. So, for example, I want to check if a point I have is not on the line, or maybe it is on the line. So, for example, I want to check, let's see. Yeah, we'll just say verify if minus 327 is on, let's say, y equals minus 8x plus 3. So I want to know if the point I have is on this line, or maybe it's off the line. And I'm sure somebody knows the way to check if a point is on or off the line. Does anyone know? Put the point in, yeah. So I put this one in, and I have 27 equals minus 8 times 3 plus 3, yeah. What's that? 27 equals minus 24 plus 3. So 27 equals minus 21. So this is obviously wrong, false. So what does that tell me? Is it on or off? Yeah. We have this situation. Off the line then, yeah. Did I? Let's make it 3, so. Fixed. Thank you. Okay, please write this one down. Oh, wasn't it? Okay, you have this? Yeah.
The last line I can't see.
Okay. How's that? Yeah. I don't think The classes are usually this big. I don't know what your timetable is for next week. I think the business students might be in a separate class. I don't know. Okay. Continue. Yeah, you have this? Okay. So next, let's say we look back at something like, what was the one I had earlier? Yeah, this one here. So why is it useful to write it in this form? Well, when it's in this form, we can see that m equals minus 5 over 7, and we can see that c equals minus 6 over 7. But why is that important? Well, it's important because the m and the c tell us something about the line. So the m tells us something about the line. What does the m tell us about the line? Gradient, correct. Very good use of American English. Another word for gradient, though? For British Irish English? Slope, thank you, yeah. So you can call this the slope or the gradient, grad. Yeah. I usually say slope. In the exam it'll be slope, but most likely gradient. But what is the slope of the line? What is that telling us? What's another way to describe slope? Like if it has a big slope or a small slope, what does that mean then? Something. Area. Yeah, what's a nice word to describe that? Other than slope. Not quite area, no? So think about this. If you're walking up a hill and it's very difficult because the hill is like this, what adjective do you use to describe it? Say the hill is steep. Yeah. So slope is like steepness. It tells us how steep or not the line is. So if, for example, the slope was something like, let's say, 2, what that means is for every 1 unit out, the line goes 2 units up. So this is a slope of 2. If it's a slope of minus 2, the only difference is for every 1 unit right, it falls 2 units. So the line is like this then. Good, okay. So that's slope. Now what does this tell us, the c? True. It is a constant. So what? What does it tell us? What's it called actually? Yeah? No. Good try. Anyone know its name? Yeah? Y-intercept, yeah. Y-intercept. And what is the y-intercept? Yeah. It's this number here, where it crosses the y-axis. So for example, maybe in my picture here it looks like C is like 2. Here, this is 1, and if it's negative, it's down here then. Yeah. So the advantage of writing it in this form is you can get the M and the C. And the M tells us the steepness, and the C tells us where it crosses the y-axis. Okay. Let's have a look at an example where we want to draw a line. Okay, so there's a couple of ways to do it. I'll show you 2 ways to draw the lines. Oh, by the way, actually, I forgot to say, whoops, come on. What's this slope if the line is like this? It's horizontal. What's the slope, the m? 0. And what about like this? Error, correct. This one here has no value. It's not defined. So we only have slopes if they're not vertical. Okay. Right, can I scroll down? Yeah. Okay. Okay, so give me some verbs that mean draw. Other verbs that mean draw. So we have draw. Illustrate, great. Let's keep it a bit simpler though. Illustrate is good then. Something simpler. Not too simple. In between. Make is a bit too simple. Well, make is fine. Illustrate's fine. Visualize. Okay. Tone it back a bit. Huh? What about sketch? Plot. And one more that begins with a G. Say again? Graph. Okay. Now, it might not seem like it matters too much if you use the word illustrate, visualize, show, make, draw, sketch, plot, graph, but it does for the exam, because depending on the word, it tells you how accurate, how neat they want the graph. Okay? So, if they said something like plot, this means they want a very neat, very clear graph. And the key thing behind plot is they always want to see points. So the graph must have clear points on it. Okay? So plot means very neat. Okay? Sketch does not. Sketch means you could draw it just quickly with your hand. Okay? It doesn't have to be so neat. So it could be just more a quick drawing like this. And sometimes they want a point and sometimes not. Okay. What about graph? Very neat or not so neat? Very neat. No, yeah, graph is. And then draw is the same as sketch here. So yeah, so basically the difference is this one you should use graph paper, whereas this one you can draw it in your notebook. That's the difference here. That's important for the exam, because if the question said plot and you just drew it in your notebook, then you don't get full marks, because they wanted you to use graph paper. Okay, so please make note of those words in your notebook, the vocabulary here. What about illustrate now? Where would you put illustrate? I think it's kind of in the middle, but if I had to pick, I'd say notebook. Because you can also use illustrate in English to mean like illustrate a picture, draw a picture, you know. What other words did we have? Is there any other one? Visualize? Yeah. Yeah, what about something like visualize then? What would you think? Yeah, it's past notebook and it's just up here, is it? Yeah. It'd be like notebook. Yeah. Okay, let's continue then. Please note those words for the exam. It's so difficult for me when I correct exams and students lose marks because they did their graph in the wrong paper. That's heartbreaking for me. Okay, so please don't do this. Okay, let's continue then. So let's do our first drawing example. So, I just want you to draw, let's say, minus 3x plus 8y plus 7 equals 0. Now, there's two ways to draw this, and it really depends on what the question wants. So, the first way I'll draw it is just like this. I don't ask you for anything else. I just say draw. So in this situation, this is the one that doesn't have to be, the graph doesn't have to have a lot of information on it. The only thing I really need to know to draw this quickly is the m and the c. So let's get that here. That will be 8y equals 3x minus 7. Yeah. So then y equals 3/8x minus 7/8. So if I wanted to draw this quickly, very, very quickly. There's x, there's y. If I say this is minus 1, and this is 1, and this is 1, and this is minus 1. So the c is minus 7/8. So that would be around about here. And the slope is positive. Is it big or small? It's quite small. When I move 1 unit, I go up 3/8. So nearly half. I go out 1 and I go up about half a unit. So if I was to roughly draw that, that would be something like, well, maybe not even as steep as that. That's too much, isn't it? To be roughly. You think that's too steep? Let's see. I'm spending way too much time on a quick graph here. Okay, so let me just extend that here. Close enough. So this is just a quick graph here. Now in the next version, I'm going to change this. I'm going to say draw, but also, yeah, well, almost like plot. I want you to show the x and y intercept. So what I also want you to do on the graph is tell me this point and this point. Okay. So we need to work out those points. So what's special about this point? Well, this point here, what's special about it is it's on the x-axis. And anything that's on the x-axis, the value of y is 0. So I already know that the y value is 0 here. And in fact, I already know this value here. But I'm going to pretend I don't know it because I'm starting again from the beginning. So I know that the x is 0. Okay, so let's start again from the beginning. Let me just scroll up for a second and to the side here. Okay, so let's say I want to find where it crosses the x-axis. I have to let y equal to 0. And then this can tell me the x value. So that means I have minus 3x plus 7 equals 0. So x equals, what's that, 7 over 3. Likewise, I can let x equal 0 to get where it crosses the y-axis. I already know the answer though. It's, what was it, minus 1, was it? Minus 7 over 8, that was it, yeah. So let's see if I get the same answer here. Let x equal to 0. I have 8y plus 7 equals 0. So I get y equals minus 7 over 8, which is what I expected anyway. So now I can put these in on the graph. So this one here is 7 over 3. And this one here is minus 7 over 8. And this is called the y-intercept. And this one here is the x-intercept. X-intercept has another name though. I wonder if anyone knows it. Another name for x-intercept. No? No one? No one? Impossible? No? Okay. I'm sure you'll know it as soon as I write it down. Also called the root. Oh, yes, of course. Yes. But you knew that. Yes. So often I don't say x-intercept and the question doesn't say x-intercept. It's quite normal to say root when you mean x-intercept. We never say root for y-intercept. This is only used when we are talking about x. Okay. Alright, let's continue then. Can I scroll down? Yeah. Okay. So what we haven't done yet is we haven't seen how can I find the line if I know two of the points? So for example, let's make a graph here. And let's put 2 points on it. So let's say there's a point here, which is 1, 1. And then let's say there's another point here. That's not so great. Let's put it like here. Let's say that's 2, 1. And we'll just draw our line. Okay, and I want to find this line, the equation of this line. So I'm looking for the M basically and the C. That's what I want. Now, the good news is we have a way to find M. Yeah? This looks bad. Oh, this looks terrible. Let's make that a 4. Yeah, okay. At least now it's reasonable. So now I'm looking for the M and I'm looking for the C. The good news is we have a way to find the M easily. We can use a formula to find the M. I'm sure somebody knows it. Somebody knows it. I know somebody knows this. Nope. Nobody remembers that formula for M. Your middle school teacher will be so sad. Oh yeah, but what's the formula? The rule? X minus? No. Half? Oh no. No half in it. No. Y2 minus Y1 over X2 minus X1. So here this will be 4 minus 1, yeah, over 2 minus 1, which is, as you said, 3. That's good, but that's only half finished. We still need to find the C. So we have Y equals 3X plus, but we still need to find the C. Very good, yeah, you can substitute in a point to find the C. Because earlier we know if a point is on the line, then it's true. The equation is true. It doesn't matter which one to choose. We can choose this one or this one, we get the same answer. But there is an easier one to choose. Which should I choose? Yeah, because 1 is smaller than 2, as you know. So if I put this in here, I get 1 equals 3 plus C, so C equals minus 2. And then I'm finished. Y equals 3x minus 2. This is my line then. Yep. Okay, so please write this example down. Okay, you have this? Yeah? Okay. Right, so the last thing to have a look at is two special types of lines, horizontal lines and vertical lines. So horizontal lines are lines like this. They just run across like that. It is a little bit different, the equation of this line. In fact, it's easier to find. I only need to give you 1 point on it. That's enough information. So let's say it's the point 2, 3. But the equation here is something that you don't calculate. It's just something from the graph, something obvious from the graph. Yeah, y equals 3 is the answer here, because on this line, everywhere, y is always 3. So this is the equation of a horizontal line. It's always going to be y equals something. In this case, 3. And now if we look at a vertical line, let's just put a small one here. And let's make the same point, 2, 3. Well, I think you figured it out. What's the equation here? X equals 2. Because, for the same reason, every point on this line, X is always 2 for this vertical line here. Okay, so just make note of this. These are two special cases, horizontal and vertical lines, special cases. Oh yeah, and just before going on, because more than one person is thinking this. In this example here, somebody here, I can read your mind, I can feel it, you're thinking, oh, why can't I just use this formula? And you can, that's fine. If you want to use that, you can use that one. I don't use it this way, I do it this way. But if this is what you learned in school and you want to use this formula, that's fine. You can use that. I don't really feel it's that much better because you still have to do the same amount of work. First, you still have to find m. And after the m, you have to rearrange it. What did I do? First, I had to find m, and then I had to rearrange to get the c. So it's not any faster or slower. There's no advantage to this. The only disadvantage is this means there is one more thing you have to remember. And you will forget many things. So I'm trying not to give you more things to remember than you need to. Okay? Right, so homework, and you can start working on them now. These questions are quite short, they're not too difficult. So on just page 2 there, you can see there's 9 questions. If you could do A and B in each question, and you can start them now for 5 minutes. A and B in each question. Yeah, so like 1AB, 2AB. It's okay, I'll get it. You sit down and do your maths. That's much more important. Called what? Oh, that's a word we never use here. Yeah. You learned through English? You learned through English? You did your maths in English, or yeah, and they use this word. Interesting. What country or what syllabus?
Malaysia, but I use the Singapore syllabus.
Ah, so this is what they say in the Singapore syllabus for axis.
Not a lot of times.
Sometimes.
Yeah.
Really? Okay. I have never ever seen that word in an exam here, but so you don't have to remember that one. But it's good to know. Yeah.